Hello everybody, welcome to one and all present here. I am the student of MIT Academy of Engineering. I am in second year civil branch. Today I am here to present the topic which is what is soil compaction. So first of all, the statement given is compaction. What is compaction? So from this word, as soil contains mainly two components, which is air plus water. Soil contains air plus water, as soil contains air plus water, and if we are remove the air void and the layer from the soil, then that process is known as compaction. And if we will remove the water percentage, then that process is called consolidation. And these both processes are very different from each other. So now consider volume of soil equals to volume of solid plus volume of air. So from this equation, as after the process of the compaction, the air void gets fully removed. So therefore, but it is fully removed means it is not up to 0% air void, means it is removed up to its highest limit, and so therefore volume of the solid get constant. It will remain constant. Volume of solid. So therefore the volume of soil equals to volume of solid plus volume of air void. It will get removed and volume of solid get constant. So therefore now considering one formula which is of tri-unit weight. Tri-unit weight of water sigma D equals to G sigma W upon 1 plus E, which is when E dry unit weight is inversely proportional to 1 plus E, and from this equation we come to know that as E is decreasing, sigma D is increasing of the soil. As sigma D of the soil is get increasing, shear strength of the soil get increasing, and because of the shear strength, bearing capacity of the soil get simultaneously increasing. And from this point we come to know that as the bearing capacity of the soil get increased, there is the inversely proportionally permeability of the soil. So the permeability of the soil get increased, and permeability of the soil get decreased, and there will be a less flow of water, or it will be a stoppage of flow of water from one phase to the another phase. Then as the bearing capacity of the soil will get increased after the process of the compaction, the permeability of the soil get decreased. So therefore now come to a point that as if we are transferring one particular area of the soil to the another particular area, if this is a particular area of the soil, and if we are transferring to the another particular area, so after the process of the compaction, so what will happen after the process of the compaction? Because of the compressibility of the soil, the intermolecular spaces is get less, and the intermolecular molecular forces will get closely packed, and so therefore the original area will get less. Like original area this is, and after the compaction the area will become like this. After compaction process, so from this the original area like this, and because of the process of the compaction the area will get less from the previous one. So now considering one block for the result of the compaction test, as the question arises up to what limit the soil will compact. So we can say that for the theoretical soil sample, up to what limit soil will compact, I have drawn one small black block for you, which is in which I have assumed the description: heavy Indian standard Proctor test, light Indian standard Proctor test, standard Proctor test, and Proctor test, in which I have assumed volume of mound, weight of hammer, height of free fall, number of layer, number of blows, in which we have to calculate the ratio of energy of heavy Indian Proctor test to the energy of light Indian Proctor test, in which I have given like volume 1000 cm3, weight of the hammer 4.9 kg, number of layer 5, number of blows 25, and you can see and you can take the screenshot of it, you can take the pic too. So therefore now we have to calculate the ratio of the energy of heavy compacted test, energy of heavy Indian Proctor test as if for the process of the compaction, if we are hammering up and down, so there is imparting which energy imparting, there is imparting only the potential energy. So what is the potential energy? Potential energy equals to the mgh, where m is the mass, g is the gravity, and h is the height. So considering this and taking this calculation is like, from as we have taken the calculation from the block as we have assumed, so 49 into 9.81 into 0.45, as there are five, number of layers are 5 and number of blows are 25 as we have assumed. So considering that also, what is the calculation? 2703.88, as calculation is like this. The energy of the heavy Proctor test is 2703.88. now we have to calculate the energy of light Proctor test, energy of the light Proctor test. So the energy of the light Proctor test is also the mgs, which is potential energy, and this will come like 593.81. as now if we will do the ratio of, and if we will calculate the ratio of energy of high Proctor test to the energy of light Proctor test, energy of heavy Proctor test to energy of light Proctor test, then as we have come 2703.8 and 593.0145, so this will come as 4.56 approximately. So therefore we can say that energy of heavy Proctor test is equal to 4.56 that times of energy of light Proctor test. So therefore now consider what is the result of the compacting test. So we can consider theoretically result of compaction test. Result of compaction test. What is the result of the compaction test? If there is an empty mold and if we are molding by the hammer, then considering empty mold equals to W1, if we are adding soil to the empty mold, and what is the weight of the soil, we have to calculate the weight of the soil. Considering empty mold equals to W1 weight of the soil plus W1 equals to W2. So weight of the soil equals to W2 minus W1, and weight of the soil is W2 minus W1. So we have assumed the volume of the soil equals to V. If we are assuming volume of the soil, from this whole process we have to find out the bulk unit weight of the soil. So therefore the bulk unit weight of the soil, theoretically we have assumed we have to calculate the bulk unit weight of the soil. What is the bulk unit weight of the soil? This is the main formula. Unit weight of soil. So bulk unit weight of the soil is weight of the soil, which is W2 minus W1 upon volume of the soil. This is the last bulk unit weight of the soil. This is the bulk unit weight of the soil, W2 minus W1 upon V. Now considering one formula, and I am showing what is the 0% air void. What is the 0% air void? I am considering one formula which is sigma D equals to 1 minus Na G sigma W upon 1 plus Wg, where G is the specific gravity, this is the dry unit weight of the water, dry unit weight of the soil. So therefore practically we know that N, as N is the air void, so N is not equals to, never equals to 0, but we have assumed theoretically N equals to 0. As we have assumed N equals to 0 and putting this N equals to 0 in this equation, then sigma D equals to G sigma W upon 1 plus Wg, and this whole equation is the 0% air void equation. And this equation of 0% air void happen when, as this equation happen when, as theoretically we will see that as fully air will get removed, and up to then somewhat level, up to high level, the water will get increased, and beyond the level the water will get suddenly decreased. So air void get decreased, water will get increased, and beyond somewhat level water get decreased. So now we have to consider practically one equation which is practically we are considering which is sigma d equals to G sigma W upon 1 plus E, where E equals to the air void and E equals to ES, as ES equals to WG, and we have to calculate the value of E equals to WG by S. And if we are putting this value in this equation, then what will come? Sigma D equals to G sigma W upon 1 plus WG by S. And this means that this equation is when as we do, or any owner do the process of the compaction, and after the fully process of the compaction, as we know that after the process of the compaction the soil get compressed and the intermolecular forces get closely packed and the air get removed and the layer get also removed. So therefore, as before, the soil is considered as the partially saturated soil, but after the process of the compaction soil will become as fully saturated soil. So the value of fully saturated soil, so this is the saturated soil, fully saturated soil or 100% saturation, and the value of soil is, the value of this is S equals to 1, and if you put in this equation, then this equation will become sigma D equals to Wg, then equation W, sigma D equals to G sigma W upon 1 plus Wg. This equation is only known as saturated soil or 100% saturation soil equation. This is the main equation. This is the main equation. So now we have learned the process of the compaction, how compaction is done and what is the compaction. But mainly, what are the application and what are the advantage of it? So mainly, we will consider what are the application. We will see what are the application of the compaction. So mainly, as we have learned this full process, so first application is filling of the soil. This is the main concept. And secondly, before the construction of any building, road, railways, bridges, or we can say for the construction process, it is importantly needed for the construction process before building any construction. So now we have to see, these are the application of compaction, and now we have to see what are the advantage of the compaction. So advantages are, this word plays main important role in this process of compaction. So advantages means, as I have earlier told, that if any owner is constructing the house, and if he is not doing the process of the compaction, then the soil will get suddenly settled down, the soil will get spontaneously settled down, and there will be a harsh condition for his building. As the soil gets spontaneously settled down, the building will get laid down, building will damage, building get destructive, and it will be a harsh condition for the owner life. So therefore, this compaction process is very, very mandatory and very, very essential before construction of any building, before construction of any bridges or roads, you can consider. And so this compaction process plays very important role in the geotechnical engineering. In the geotechnical engineering, before construction of any houses, residential buildings, road, bridges, etc., or we can say this plays very important role. Compaction plays very important role in the civil engineering process. So thank you for listening me. Hope you like my video. Thank you.
कर बंद.